Hi, everyone. Thank you for the introduction. I'm very happy to be here. It's my first talk since the pandemic, so it's nice to see people in real life. My talk will be about who are the MLOps. I guess inside Yelp, we have quite a mature sort of team serving as the function of MLOps. And so my team is called Core ML, and I would say 80% of our daily function is probably along the MLOps side. I guess most of us are from software engineering backgrounds, and in the talk, I hope to share with you what we do day to day and how we transform the prototypes we build. So maybe some of the research, like in the previous talk, into production. So before we start, I want to just do a show of hands from the audience. Who is already an MLOps in the audience? Cool. Great. Who might be a data scientist or another engineer who works, or product manager, whatever, but who works with an MLOps actively? Cool. Who is a DevOps? Who would identify themselves as a DevOps? Who works with an DevOps actively? Cool. And who is in a data or ML-orientated team? Great. You're in the right conference, I can tell. So I guess for the folks who kind of raised your hands for the third and fourth question, you're probably familiar with this diagram, the sort of traditional CI/CD pipeline where you build, test, deploy, but in a circle, in a continuous fashion. So I would say for an MLOps, our function is probably pretty similar with a few kind of added seasoning. So what would it look like for the ML services? So let's assume a problem that we encounter very often at Yelp. So who's heard of Yelp, actually? Raise your hand. Great, okay. Saves me a lot of introduction. So at Yelp, we're basically, we are built for small businesses. We provide reviews. We provide sort of listings for small businesses. So one of the problems we encounter very often, we have a lot of restaurant reviews on our website, and users like to upload their photos for those. So we often have a problem of recognizing those images and labeling them accordingly. For instance, if we had a problem today of telling the drinks that's served in a cafe from the dishes that's served in a cafe, we would probably need the following: the training data, meaning the user uploaded photos, the test data, again, also user uploaded photos, but maybe user have already labeled them, and then we would need a learning algorithm. Throughout the presentation, you'll probably see that I have some of the terminology written in the kind of Spark specific way. It's also like an estimator. In Yelp, we use Spark pretty much for all our batch processing. We also have Flink for some of that, but mostly Flink is used for the real-time purposes. So with all of the above, ideally we should get to the following, where we will have a machine learning model which can be used to serve, to label, to classify these data. So architecturally, it should look like this. Linearly, it should look like this. So the first step, you would have data collection, and then you'll train the model, you'll test the model on the test data, you deploy, and then you monitor. But it's all very nice kind of having this linear way of doing stuff, but what if we have new training data coming in? So maybe with those data, we can improve the accuracy of the model. What if during the process, we built a lot of features in these images, maybe the darkness, maybe the time of the day that the image was taken, all these features, maybe some other teams want to use them as well. Also, I had the assumption of like classifying drinks from dishes, so that would be like a binary classifier. What if we want to add more classes to the model? Ideally, we want to get to sort of a workflow like this, eventually from linear to continuous. So using this sort of flow, it will resolve a lot of the problems we've just mentioned before. For instance, if you have new data coming in, after you've deployed the model, you can continuously pump in those data. Also, if the model drifts or like sometimes it happens, the more data you put in, the performance of the model actually degrades. So you want to demote those models. That could also happen, but with this sort of like continuous flow, you can prevent that from happening, and you can also operate on those models on a continuous basis. So let's look at each, just so you had a look at it, but let's look at these stages in more details. So the first step really is data collection and pre-processing. So in that stage, we want to kind of check if there are missing values, there are skew or biases to the data, and also if the data is up to date. We have, for instance, inside Yelp, we have like validators and various pipelines to check if the data was like older than the newest model we have. So we kind of make sure that they are in the right place. We also check for missing values, so we have active metrics to check how many zeros there are, how many nulls there are. Also for skew and biases, it's something we really care a lot about. So for the data, sometimes we would even not try to train models if they're like too skewed. There are times where you can adjust the biases by oversampling and things like that. But sometimes we would actively just say this data is not good enough and let's wait maybe for a little longer to build it up. So as I've kind of already mentioned, these are the methods we actively have. And all of these we have kind of metrics. We have Prometheus metrics. We also have some legacy platforms, and people can see these things coming in, and they can actively view all the metrics on these. So during the model training and validation/testing stage, typically we would, from the MLOps perspective, we actually will compute the amount of resources they need. So for instance, if you have a data set of 1 billion rows, the input size is this much, we provide these things on demand for you. All of our compute batch processing is built on top of Kubernetes. So we can on demand schedule the resources for you. We can request them on demand. So we don't, especially for the GPU side, we don't have the reserved instances because they're very expensive. So we provide when the customer comes to us, or if their batch is scheduled, then it'll basically be there, only come up, and we only pay AWS when we need to pay them. Post-validation, post-training validation, so using the tests, again, there's pipelines built in place. Most of our things internally, we have something called Tron, which is a fancy cron scheduler with built-in job dependencies. So maybe a little bit like either Kubeflow or Airflow, but the platform that we had has been there for ages, and it's not just used for machine learning purposes. So that is continuously being used, and we actively swap out the underlying kind of computing platform. So it moved from Yarn to Mesos to Kubernetes now. So I guess all of these pipelines are in place that it supports the post-training if we have any sort of post-training jobs kicking off once the model is ready. Those platforms sort of support it. We also have MLflow, so that kind of helps us to track the models. We have the metadata publication. There's some fancy UI, not really fancy, but there's UI that you can see with all the kind of model parameters, model kind of ID, things like that. So we have all of these to support our kind of training and validation. So during these stages, I think as an MLOps myself, day-to-day, most of the time, and the biggest barrier is probably resource intensivity to the models. So if you have very, very large input, we can run 300 pods like in parallel for you to train the model, but it becomes very sensitive. So any of the pods, if they run out of GC, they run out of memory, they run out of any small thing, it causes it very sensitive to failure. So during that stage, we do have monitoring in place as well, just so people can look at it themselves or come to us, and we'll help them figure out what's the best kind of provisioning of resources during those stages. Obviously, underfitting, overfitting is all very big problems. Again, you still want metrics to tell you about the model performances. And you also want to do that on a continuous basis, because when new data come in, those can be like new problems that occur with them. So productionization and post-deployment. All our models are basically REST kind of services. So once the model gets deployed, it will just become a REST service. We have a cookie cutter for that. So then the APIs are kind of generated. The boiler code for that is also generated. MLflow, like I mentioned, we can use that to track the model metadata. Once it's deployed, you can also track like kind of the progress of certain things. Again, we have other metrics for monitoring the model performances. Drift is a thing that we all kind of fear. A lot of times it's due to undocumented changes. So the main thing I think we try to keep in place, so we have feature store that tracks all the schemas, and I would say probably 95 or 98% of all our data structures are schema'd. So that drift is harder to happen in those cases. We also, feature store is also obviously used for tracking lineages and the history of the data. So those things kind of are there to help engineers from day to day. Yeah, like I mentioned, there's pipelines to demo models, tools, anything you can think of. We have a bit of everything. Jenkins, a little bit legacy on some of the newer, not necessarily newer, but some of our open source projects, because Yelp actively open source. For instance, Tron is actually open source, although we use it internally, but it's also open source. All those things have GitHub Actions for pipelines, and yeah, there's pretty much everything you use for DevOps, anything you use for the build, test, deploy, it's kind of still applicable in these stages. So I've talked a lot about how the different stages work in MLOps. Just to tell you a bit more in detail how we structure our core ML team inside Yelp. And we mainly kind of divide that into 3 functions. We have ML compute, which is the team I'm in. I look after mostly the computational resources, so it's pretty infra heavy. We deal with provisioning all the Kubernetes resources. We don't use EKS, so we actually run our own Kubernetes on AWS. We make sure that's scalable. We have our own kind of cluster and our own shards. So I would say, yeah, the side of machine learning is probably the heaviest user. Unfortunately, of Kubernetes, it's very costly, but it's also good that we have that because that does provide a lot of the on-demand access so that we can reduce cost. We also have the model platform team. They take care of most of the metrics side, so anything to monitor the model performances, any of the post-production kind of degradation monitoring, stuff like that. They maintain a lot of the open source kind of libraries in-house so that they kind of build templates around them. There's like notebooks, Jupyter notebooks they write, which kind of are based on some of these so that people can almost plug and play if they find the correct usage. Also, one thing to mention, from like the talk is about prototype to production. So inside Yelp, we have Spark integrated with Jupyter Hub. So a typical workflow for a data scientist would be to open the Jupyter Hub, maybe just sample a bit of the data inside Jupyter Hub with all the nice visualizations. They can open the Spark session on top of that. So by that point, the Jupyter Hub notebook is already multi-machine. So you can run like 10 pods to just, even on the sample data set, to kind of work out what you need to do. And directly, once you comment out the stuff like df.show, it can be scheduled at that point with all the parallelized kind of resources provisioning. And at that point, it's almost already productionized. So this flow is super, super, I would say super, super continuous. And it's really nice that we have that in Yelp because I think a lot of the time, people spend ages to just turn a notebook into the actual productionized service. Last but not least, feature store. We have, during the processes of machine learning, we have a lot of reusable features. So we want to share them, lineages, metrics. We use Calibra mostly. We have a lot of validators. We have caching. We have all different kind of utilities built by the feature store for that as well. So to summarize, typical 3 stages: data collection, pre-processing, model training, validation, productionization, and post-deployment valuation. So typical stages, but it's continuous, so it goes on. And in core ML, we are mostly an MLOps team that serves as a horizontal layer for providing common functionalities within Yelp for all the other machine learning and data-driven teams. So if you like what I talked about Yelp, just so you know, Yelp is hiring. Thank you.